Hello students, let us discuss one of the lessons for this week, which is multiplication of radical expressions. The goal of the lesson is to multiply radical expressions and simplify if possible. Before we multiply radical expressions, let us review simplifying radical expressions. Let us have number 1, the square root of 169. To simplify this, we need to write the factors of 169 in exponential form, and it is equal to the square root of 13 squared. As you notice, the exponent of 13, which is 2, is equal to the index. This means that 13 squared is a perfect square, and the answer is equal to 13. Next, number 2, cube root of x cubed. As you can see, the exponent of x, which is 3, is also the same with the index, which is 3. Therefore, it is equal to x. Number 3, cube root of 40. Here, we need to look for the factors of 40 and write it in exponential form. So it is equal to the cube root of 2 raised to 3 times 5. It's because 2 times 2 times 2 is equal to 8, then times 5, it is equal to 40. Then, from the factors of 40, only 2 raised to 3 is a perfect cube. Therefore, we can simplify it and write outside of the radicals. And that is equal to 2 cube root of 5. 5 is still written inside the radicals because the exponent of 5, which is 1, is less than to the index. Next, number 4. Fourth root of y raised to 5. Here, the exponent of y is greater than 4. And then when you divide 5 to the index 4, will not give us the exact value. So we need to factor y raised to 5 in such a way one of the factors has the exponent that can be divided to the index. And it is equal to the fourth root of y raised to 4 times y. Then the fourth root of y raised to 4 is equal to y. Then fourth root of y. Next, number 5. Fourth root of 80. The factors of 80 is written as 2 raised to 4 times 5. It's because 2 times 2 times 2 times 2 is equal to 16. Then times 5, it is equal to 80. Then, the fourth root of 2 raised to 4 is equal to 2. Then, fourth root of 5. So, our answer is 2 fourth root of 5. Number 6, the fifth root of x raised to 17. As you observe, the radicand x has the exponent of 17 that when you divide to the index will not give us the integral value of the exponent. So we need to factor x raised to 17 in such a way that one of the factors has the exponent that can be divided to the index 5. So it is equal to the fifth root of x raised to 15 times x raised to 2. This time, one of the factors of x, which is x raised to 15, has the exponent, which is 15, that can be divided to 5. And it is equal to x raised to 3, and then copy the fifth root of x raised to 2. Therefore, our final answer is x cubed, the fifth root of x squared. The number 7, fourth root of 81x raised to 17. The same procedure, we will going to factors the radicands, and it is equal to the fourth root of 3 raised to 4, x raised to 16 times x. The factors of 81 is 3 times 3 times 3 times 3, or in short, it is 3 raised to 4. And then, x raised to 17 is x raised to 16 times x. So, To simplify it, it is equal to the fourth root of 3 raised to 4 is equal to 3. Then, the fourth root of x raised to 16 is equal to x raised to 4 because 16 divided by 4. So, our exponent is 4. And then, the fourth root of x. So, our final answer is 3x raised to 4, fourth root of x. To continue, in multiplying radical expressions, we are guided this rule, which is x, the nth root of a, times y, the nth root of b. It is equal to the product of x and y, or your coefficient, and then the nth root of the product of a times b, which is known as the product rule. Observing the rule, we can only multiply radical expression which has the same indices. To multiply radicals, it is suggested to follow these steps. First, multiply the coefficient. Next, multiply the radicand. If the indices are not the same, convert radicals into expressions with fractional exponents. Then express it as similar fractional exponent. Lastly, simplify if possible. Now, let us multiply the following radical expressions. Number 1, negative 2 square root of 8 times 5 square root of 2. To follow the steps, we need to multiply first the coefficients, which are negative 2 times 5, followed by the product of the radicands, that is equal to the square root of 8 times 2. Negative 2 times 5 is equal to negative 10. Square root of 8 times 2 is equal to the square root of 16. The square root of 16 is equal to 4. So our next step is negative 10 times 4. Finally, the product of negative 10 and 4 will give us negative 40. So our answer is negative 40. Number 2, 7 cube root of x squared times 4 cube root of 2x squared. First, we need to multiply 7 and 4. So that is equal to 7 times 4. Next, the product of x squared and 2x squared, that is equal to the cube root of x squared times 2x squared. The product of 7 and 4 will give us 28. The cube root of the product of x squared and 2x squared is equal to the cube root of 2x raised to 4. Here, we need to simplify x raised to 4 since the exponent is greater than to the index. So this can be written as 28 cube root of 2x times x cubed. X times x cubed is the factored form of x raised to 4. This time, we can now simplify the cube root of x cubed and will give us x. And it is written now outside the radicals. So it is equal to 28x cube root of 2x. Our answer is 28x cube root of 2x. Number 3, fourth root of 81 y raised to 17 times negative 6 fourth root of x raised to 8. It is equal to 1 times negative 6. 1 is the coefficient of the first radical. Then, the product of the radicands, that is equal to the fourth root of 81, x raised to 8, y raised to 17. 1 times negative 6 is equal to negative 6. And then the factored form of the radicals is the fourth root of 3 raised to 4, x raised to 8, y raised to 16 times y. 3 raised to 4 is the exponential form of 81. And then y raised to 16 times y are the factors of y raised to 17. So that is equal to negative 6. The fourth root of 3 raised to 4 is equal to 3. The fourth root of x raised to 8 is equal to x raised to 2 because when we divide the exponent of x, which is 8, to the index 4 will give us 2 as the exponent. And then the fourth root of y raised to 16 is equal to y raised to 4. Because when we divide the exponent of y, which is 16, divide by the index 4 will give us 4 as the exponent of y. And then the other radicand, which is y, is still written inside the radicals. So that is fourth root of y because it has the exponent of 1, which is less than the index. Finally, we have negative 18x squared y raised to 4 fourth root of y. Negative 18 is the product of negative 6 and 3. So our answer is negative 18x squared y raised to 4 fourth root of y. Then number 4, square root of 3 times the quantity square root of 12 minus square root of 7. To answer this, we will multiply square root of 3 to each term of the binomial radical. So that is equal to the square root of 3 times 12 minus the square root of 3 times 7. And then it will give us square root of 36 because the product of 3 and 12 is equal to 36 minus square root of 21 because the product of 3 and 7 is equal to 21. The square root of 36 is equal to 6 minus square root of 21 is already in simplified form. So that is square root of 21. So therefore our final answer is 6 minus square root of 21. Number 5, the square root of 2 times 4 the cube root of 5. Did you observe something? Yes, we cannot multiply them right away because they have different indices. All we need to do is to convert it first into rational exponents. So that is equal to 2 raised to 1 half times 4 times 5 raised to 1/3. And then we need to look for the least common denominator of 1 half and 1/3. And that is equal to 6. So 6 divided by 2 is equal to 3 times 1. So 2 raised to 1 half will give us 2 raised to 3 over 6. And then 6 divided by 3 is equal to 2 times 1. So 1/3 is equal to 2 over 6. So it is equal to 4 times 5 raised to 2 over 6. Then let's go back again by changing this into radical form. 2 raised to 3 over 6 is equal to the 6th root of 2 raised to 3. The denominator 3 will be the exponent of 2 times 4, the 6th root of 5 raised to 2. Then let us multiply. That is equal to the 6th root of 8 times 4, the 6th root of 25. Then that is equal to 4 and then the 6th root of 8 times 25. 8 times 25 is equal to 200. So therefore our answer is 4, the 6th root of 200. Then number 6, 3 cube root of x squared times negative 6 fourth root of x. The same with number 5, they have different indices. The first one has the index of 3 and the second one has the index of 4. So we need to write this into rational exponents. So it is equal to 3 times x raised to 2 over 3. The exponent of the radicand x will be the numerator and then the index will be the denominator. And then times negative 6, then x raised to 1 over 4. And then let us find out the least common denominator between 3 and 4, and that is 12. Then 12 divided by 3 is equal to 4 times 2 will give us 8. So that is equal to 3 times x raised to 8 over 12 times 12 divided by 4 is equal to 3 times 1. So it is equal to negative 6 times x raised to 3 over 12. Then, let us write this again into radical form. It is equal to 3 the 12th root of x raised to 8 times negative 6 the 12th root of x raised to 3. Then let us find out the product of the coefficients. That is 3 times negative 6. And then the product of the radicands, that is the 12th root of x raised to 8 times x raised to 3. 3 times negative 6 is equal to negative 18. And then the 12th root of x raised to 11. Because when we get the product of x raised to 8 and x raised to 3, will give us x raised to 11. So our final answer is negative 18, 12th root of x raised to 11.